Hello stats and welcome to 6.2. This is real application of normal distribution. So that means we no longer have a mean of 0 and a standard deviation of 1. We're going to use what we actually find, so this makes more sense. All right, make sure you got stat this up and let's go. All right, a normal distribution that is not standard. So we are talking about not standard ones today. Okay, the probability, we will find the probability of some range of values, and we will find x-scores. All right, so not standard means the mean is not 0 and the standard deviation is not 1. This is what we've been finding all along, but now we actually get to put it into terms. Now you also have to remember our formula that z is equal to x minus the mean divided by the standard deviation. So just in case you forgot, this is the mean and this is our standard deviation. All right, and that finds us our z values. And we're going to use that to work through this. So now our mean and our standard deviation, our z-scores, actually have values, where here are x values, and z and a z-score here. These were 0 with a straight z-score here. So this is an x value now, not a z-score. All right, so to do this, we are going to sketch a normal curve, just like before, nothing's changed. We're going to label the mean and the x value that we're trying to find, and we're going to shade where we're looking for. We're going to find the z-score that we need and convert that so we can plug that into StatDisk. And then we're going to use StatDisk to find this. We are not going to use the table A. You can use the table A2 if you are at home and don't have StatDisk up, but I'm not going to here. All right, here's an example. We have a proportion of men are taller than 72 inches, because this is the height requirement for a shower head. So how many men are too tall for a standard shower when we walk in is what we're looking for. Now, heights of men are normally distributed, so I got a normal distribution with a mean of 68.6 and a standard deviation of 2.8. So now we know we have a mean, which is mean, and our standard deviation of 2.8. Find the percentage of men who are taller than 72 inches. So who is 68.86 is my average. 72 is how tall they are. I want to know how many men in here are too tall for the shower head is what we're asking. So first thing we have to do is we have to convert this 72 into a z-score so we can type it in StatDisk. Now remember, z-score is x minus mu over sigma. So it's 72 minus our 6.86 divided by 2.8. Now, if you round to 2 decimals, that's what your book does. I do not like this. I want you to go out to at least 4, if not 5. Okay, I prefer 5 decimals. We get a better, more accurate reading. So this one, when you did it, you should have had 1.21429. All right, now we're going to take StatDisk and plug that number, let me get back to it, into it. So now this is my z-score, so we're up here. And we're going to type in 1.21429. Enter. And we get an area of point. Now we went to the right because it's the larger, so looking at the 0.11232. And we're done. That is all we need to know. So now if you are not using StatDisk, you will have to use this with the table. Okay, if you're on StatDisk, you're going to look from the area to the right, and it will give you this answer immediately, which is very nice. Actually, you would get 0.11232. This means 11.23% of the men are taller than the 72 inches that is a required height. That's quite a bit, actually. So now I want you to stop and see how many if raising it to 76 inches would make a difference. Okay, first step, you should have found your z-score. Your 76 minus 68.6 divided by your 2.8. Remember, you're rounding that out to at least 5 decimals. So you should have 2.64286. You should have typed that into your stat disk. So the probability needed to be greater than 2.64286. And when you looked at the left side, you would have got 0.00411, which means 0.4% of men would be taller than a 76-inch shower head, which is not very many. I know that's, you can't get everybody, so this is a good idea. This here would raise it significantly. Now let's check if it actually makes a huge difference. So you're going to take 0.11232 from above minus the 0.00411, the one we just calculated, and we get a difference of 0.10821. Now, if we're doing a 95% interval, I would say that 0.10821 is greater than the 0.05. So this is a significant difference. If we were doing the 90% interval, and we would have 0.11 would be greater than the 0.10, that's kind of iffy. It is significant, but not by a lot. So I don't know if I would change it with a 90% rate. But with 95, absolutely, it needs to be raised. And it's not hard to do. So why not make everybody happy, right? Okay, now we're going to go the other way. We're going to find values from a known area. So now you know the area, and you have to find which x values they have. First thing we do is always we sketch our curve. Nothing changes there. We're going to identify the x value we're looking for. All right, in stat disk, it's going to be probability distribution, normal distribution, enter the desired z-score, and see what we get. Now, we are still using the exact same formula. Z is equal to x minus mu over sigma, or your standard deviation. And this time you're going to solve for x. This is just showing what x looks like when you solve, because you multiply by sigma and you add your mu. So it's not too bad. All right, then you're going to check your sketch to make sure it makes sense. Here we go. We got an aircraft cockpit. Now, in order to fly, you have to be a certain height. Now, 95% of the population fits this. There are only 46% of the women who actually make the height because it was designed for men. All right. What would be the maximum acceptable height of a woman if we change the requirements for the shortest 95% of women to be pilots? So 95 or below could actually fly. That's what we're looking for. I know that a woman has a 63.7 mean. So we know what my mean is, and a standard deviation of 2.9. I need to find what percentage this is. So now we draw our curve, which is over here, and we're trying to find this x value, and we know we want this here to be 95% of women to fit in this area. So 95 or below. So we know it's everybody to the left. Okay, so let's use our stat disk to help us out. So we want 95%, so we're going to go to stat disk and type in your cumulative area, and we know that one we want it to be 95 to the left, so I don't have to subtract anything, and we get 1.64485. Oh, I should have shown you this. This is analysis, probability, normal distribution is where we're at. All right, and down here was the 0.95. Okay, so 1.64485 is what we get for our value. So we know that we found our z-score, and this is equal to 1.64485. So now that we've got that number, we can plug it into our formula. So we go 1.64485 equals x is what we're looking for, minus the 63.7, my mean, divided by my standard deviation, which was 2.9. So now you take the 1.64485 times the 2.9, that's where this came from. Then you add the 63.7 to it, and we get 68.47. So they would have to change the height requirement to 68.5 inches, and then 95% of the women would be eligible. Should we have a minimum? Absolutely. If you're too short, you won't be able to see and you're going to crash. So yes, we need a minimum height. All right, I want you to do the same thing, but now a 90% requirement for the woman. So now you should have found P of 90%. Your Z-score would have equaled 1.28155 from StatDisk. You would have typed that into your program, 1.28155 equals X, what you're looking for, 63.7, and your standard deviation of 2.9 have not changed. So now you've taken 1.28155 times 2.9. You've added your 63.7. Now for 90% of the women, you'd have to have a 67.42 or 67.5 inches. Then 90% of women could fly. All right, good luck on your homework. Now, I also want you to recognize that 6.3, there will not be recorded notes because you are expected to read that and highlight and either ask me 2 questions when we're in class or you're going to post 2 questions online. All right, good luck with your homework. I hope you do well.